So for this video, we're going to look at zeros of polynomial functions. And in order to do that, we're going to look at how to find possible rational zeros by taking the factors of the constant term and dividing it by the factors of the leading coefficient. We're going to use the list of possible rational zeros to find the real rational zeros of the problem, and then use those zeros to find any imaginary solutions that might be left over. So the first thing we want to do is take the factors of the constant term and divide it by the factors of the leading coefficient. Now remember that a constant term is any term that does not have a variable. So in this case we have 4, which does not have an x. So my constant term is 4. Now we need to find the leading coefficient, and in order to do that we want to find the highest exponent. In this case it's 4. And the coefficient that goes with that exponent, which is -1. Now we don't want to just do 4 divided by -1. We really want to do all of the factors. And remember, factors are numbers that multiply to give me the number that we want. So I can multiply by 1 and 4. 1 times 4 gives me 4. I can also multiply by -1 and -4. That will also give me +4. And then I can multiply by 2 times +2, which gives me 4, and -2 times -2, which will also give me 4. So when I look at the leading coefficient, which is -1, I know the only way to get -1 is to multiply +1 by -1. Well, this is a simple problem, and still notice that we have quite a bit left out here. So quite frequently, we just write ±1, ±2, and ±4 instead of writing out all the terms twice with a positive and a negative. Now that we have all of our terms, we want to write the list of possible rational zeros. So possible rational zeros. So I'm going to do 1 divided by 1, which gives me plus or minus 1. And then I'm going to do 2 divided by 1, which gives me plus or minus 2. And last but not least, 4 divided by 1 gives me plus or minus 4. So I can see here that there are 6 total possible rational zeros. Now not all of these are going to be real zeros, but they all could be possible zeros. Well, now we want to decide how many answers we have. So to do that, we look at the degree of the function, and we notice that the degree happens to be 4. Since the degree is 4, then 4 is the number of answers that I should have when I'm finished. So to do this, we're going to use our calculator. So when we pull up our calculator, we want to put the equation in for y equals. So notice I have -x to the 4th plus 3x squared plus 4. I want to go to second window, and I want to make sure that my independent variable is on ask. When it's on ask, that gives me the ability to put in my own x values instead of sorting through a list of 100 variables that they're going to give me. So I'm going to press second graph, and notice there's nothing here. That's because we're going to put our values in for the problem. So we're going to start with 1 and -1. We have 2 and -2. And then we have 4 and -4. So on this problem you can see that 0 and 0 pop up in the y column. Well, anytime we have a y value of 0, that means those x values that coordinate with it are real zeros of the problem. So I know 2 of my answers should be 2 and -2. So my real zeros are 2 and -2. Well, this is great, except I'm not finished yet. So remember, we still have -x to the 4th plus 3x squared plus 4 as our problem. Well, now we know some things. We know that the real zeros are 2 and negative 2. But remember, I'm supposed to have 4 answers. Well, since I'm supposed to have 4 answers, I've got to find the other 2 answers. That's how we use these 2 answers to find the remaining answers. So it doesn't matter which one you do first, but we'll start with 2, and we're going to go ahead and write the coefficients of all of the variables and the constant term after this. So we have negative 1, and then we have a 0 for our x cubed position. Then we have an x squared, which is 3. We have a 0 for the squared position and a 4 for the constant term. So we're simply going to drop the first number, just like we normally do in synthetic division. And we get negative 1 multiplied by 2, we get negative 2. Add going down, we get negative 2. Multiply by the box, we get negative 4. Add going down, we get negative 1. Multiply by the box, we get negative 2. Add going down, we get negative 2. Multiply by the box. Draw our line and add, and notice that we have 0, which verifies that this is an answer. Now that we have this one, we're going to do synthetic again with the second answer. So I'm just going to take the answers that I have from the first problem and start with the second problem. So now I have negative 2 in the box. I'm going to drop my negative 1, and I have negative 1 times negative 2, which is positive 2. Add going down, and I get 0. 0 times negative 2 is 0. Add going down, I get negative 1. Multiply by the box, I get positive 2. Now I have 0 again. Notice that we don't use the 0 on the end because it's gone. So now I know that this one is also a 0, and I'm left with negative 1, 0, and negative 1 as coefficients. Now remember, every time that we do synthetic division, we're going to drop a degree because we're dividing out a 0. So since I had 4 as my degree, now I've got a 3 and a 2 because I've gone down 2 degrees. So this should start with negative 1x squared plus 0x, which I don't have to write, minus 1, and we're solving so it equals 0. Well, now it's just a simple quadratic problem that I can solve by adding 1 to both sides. Then I can divide by negative 1, and I get x squared equals negative 1. And when I take the square root, remember I have a negative inside there, and we always get a plus and a minus, so we have plus or minus I. So this tells me that all the zeros of the problem are plus or minus 2 for 2 and negative 2, and plus or minus I. That gives me a total of 4 answers, 2 imaginary answers and 2 real zeros.